Hey guys, so welcome back. This file we will try to show how to import correctly data from a file and how to process it with in order to avoid reading empty cells and perform just a simple linear regression using the pseudo-inverse matrix method. So first of all, I need to use the Panda library. So I'm importing pandas as PD. So from Panda, what I will use the read CSV to read my travel times.csv, and you see it is directly on my root D. Okay, you could give, of course, a different path. And once I'm done reading, I'm just printing out to make sure that I read the file correctly. Okay, so now I'll just process the data. Don't forget, so df is the data frame, and I'll try to go through my data frame in order to avoid reading empty cells. So I'll go from the size which I know intentionally. I know from the beginning that I had 100 cells to read in each column, and I will try to pass the data to the 4 input files columns I have and the output file. So for I from 0 to size, so from 0 to 100, if the input which is in the data frame at I, so at the beginning at 0, for the column Tij, which is the time here in my data file. If the input is larger than 0, then I will continue. So I'll make sure that I avoid these empty cells in case I had an issue in the data file. If the day order, of course, is larger than 0, season larger than 0, day of the week larger than 0, so I make sure that I only input the data and only take the data that is necessary where the cells are not empty. If that happens, if 5 conditions are met, then I will read what is in the data frame at position I in the day order, in the season, day of the week, period, and pass them respectively to columns x1, x2, and x3, x4, using a counter. This counter, of course, is incremented only if the 5 conditions are met, so it only counts the usable data I have. So once I did this, the last one passes the output we'll try to predict, which is the travel time from a point I to a point J. So, and finally, I'll display the counter. So the counter here should be 100. Okay. Now I will do as I did in the previous videos. I will pass the 4 input columns and 1 column to Z. I will perform the pseudo-inversion using the pseudo-inverse matrix. I will multiply the pseudo-inverse matrix by the transpose of Y to get the coefficients I have I need in my linear regression. And finally, I'll multiply the coefficients by Z itself, by the input itself, to get the prediction or the linear prediction. Now for the root mean square error, I will use this forecasted error MSL, and I will compute the error of estimation. I will square it down, and I'll sum them all up and divide by the counter, which I know is 100, and put it to the raised to the power 0.5. So at the end of the day, you see that I could display here the input, the output, and the coefficient, but I'm interested with how the estimation looks compared to the original data. You see, well, it's not that bad. The overall forecasting root mean square error is for the linear approximation about 0.7. And here is the red curve is the estimation. The black curve is the original signal we had, or the original input we had at the time, travel times. Okay, so it's not that bad. We could do better, and hopefully next week we'll see how we could do better using neural networks. Okay, thank you very much for listening, and I'll continue feeding you with some of these videos. Bye.